All right, I think we're live. Welcome to
Wow,
episode number 2 of Earthsight.
number two. Here we are.
Here we are.
So we got some feedback last time that we probably should have just introduced ourselves at least a little
Yeah,
before starting. So, Krishna, do you want to start with an introduction and then I'll go?
sure. Um, let's see. I studied electrical engineering. I worked in defense and intelligence for the first 9 years out of school. Various defense contractors, working on projects like DARPA projects, IARPA projects, other three-letter agencies that you might be able to guess,
Mm-hmm.
radar, geolocation from space. Yeah, digital signal processing. I mean, that's what I studied in school, and that's what I was interested in, and I just kind of fell right into it and just stayed in that world for a super long time. And the reason I got out was partially because I wanted to see what life was like when you could talk about what you did to the outside world. And
Oh,
then,
we're talking now.
yeah, and now we're really talking. But
Yeah,
back
yeah,
then, I didn't say anything really.
yeah.
And yeah, I think the turning point for me was when I worked on something where I realized the only time we would ever turn it on, this thing on that we had worked on, was if we were about to go to war with another country. And that
Mm-hmm.
was like a wow, this is
Right.
this is serious. So
Yeah.
out of that, I fell into Descartes Labs, basically, which I think a lot of people who are listening to this probably have heard of at least a little bit.
Mm-hmm.
I guess the company was founded in 2015. I joined in 2018. It was pretty small for a while. I kind of joined like when they were doing a very significant expansion and they had done their
Mm-hmm.
first big raise, I think. And yeah, I fun fact, I sat next to Chris's wife.
Mm-hmm. Yep, that's how we know each
That's
other.
how we know each other, actually.
Yeah.
And Chris and I are actually both, we were users of the Descartes Labs platform for a long
Mm-hmm.
time. So I think we're going to get into that and talk about that a little bit. But that was my intro to geospatial stuff. Until then, I really had no background in remote sensing. I did have a background in machine learning and kind of algorithm development, but all from the RF side of things. Like I hadn't done a ton with imagery. So yeah, after Descartes, I kind of basically bounced around a whole bunch of places. Worked at Impact Observatory, worked at Series Imaging. I'm not really going in chronological order.
Mm-hmm.
I did a consulting thing where I did a little bit of work for SkyTruth, a little bit of work for a company called Understory. Yeah, I ended up I guess ended up working on a lot of different things, and then I guess my third career now is working in news. So now I'm a data journalist at Bloomberg News. So I do a lot of the same things I used to do when I worked in tech, but I do it for news and within the context of the newsroom. So that changes a lot of my day to day and my timelines and things I'm specifically interested in.
Mm-hmm.
But it's a lot of the same tools and techniques. So I think that was very
Right.
long, but that's me.
Yep. Pretty long. Pretty long.
Pretty
I'm
long.
kind of thinking maybe I should have gone first now.
You should have gone first.
This was a mistake. This was a strategic error.
Now you have to
Yeah,
beat 4 minutes.
I have to beat 4 minutes. I'm Chris, degree in physics and a PhD in material science. Until my first postdoc, I hadn't really written any code ever. I spent a lot of
Wow.
time doing actually spectroscopy, which is kind of relevant to
Hmm.
what I do now, of semiconductor crystals, which involved being in windowless labs for extended periods of time. So really not that great from a quality of life perspective.
I think we share that.
Right, right. And then I did a pretty short postdoc and then went to work for a healthcare company that
And
was
this is all in the
analyzing.
UK, right?
This was in the UK, yeah, in Cambridge, analyzing patient breath data to try and detect lung cancer metabolites.
Wow.
So that was pretty fun. And then I guess my big break, I moved to the US to do a postdoc in geophysics at Los Alamos National Lab. That was in 2018. And I think I worked on geophysical data, seismic data for about a year or two. I gotta say I didn't love it. I don't love the one-dimensional data, the squiggles.
That's right. Yeah.
I think I'm definitely more of a visual person. But there was a group
I
at
guess the
Los
seismic stuff's
Alamos.
more like RF in a sense.
Yes, very much so. I mean, you can turn it into an image with a Fourier transform, but it's
Right.
like, it's not really an image.
Right. Right. Right.
And at Los Alamos, there was a group called the Intelligence and Space Research Division that was actually kind of collaborating with Descartes Labs. Descartes had given them access to their platform, and they were doing some cool sort of algorithm development on remote sensing imagery. And I kind of lobbied really hard to work with that group, offered to work for free and just, please teach me how to pull imagery and run algorithms on it. And that's kind of how I started with Earth observation. Really enjoyed it. A lot of my work at the time for the next like 2 or 3 years was definitely enabled by the Descartes Labs platform. Like I wouldn't have known how to pull imagery actually without it. And then after Los Alamos, that was the Earth Genome, Earthrise. That's where Krishna and I worked together on embeddings, and then I had a stint at Grow Intelligence, which was a food security startup which no longer exists. And then I think I also did some consulting after that for a couple places.
Right. Right.
And now I work on weather data. So yeah, that's my story.
Cool. So we're, extremely moderately qualified to talk about some of these topics.
So moderately qualified.
So we had a couple questions from last time. I wonder if we should just we shouldn't spend a ton of time on this because I think today we wanted to talk about geospatial platforms and stuff like that. But I wonder if we should go through them real quick.
Yeah. Yeah.
We had one question on, can you expand more on how you generated what you call the expert embeddings, one without any machine learning? I want to say, I feel like we covered that one pretty well. If I had to summarize what I think those are, at least the way we did them, it was, pick your reducers that you're going to apply to like a time stack of imagery, say a year. And basically by picking your reducers, you're picking the moments in time that you want to capture. So that's in the temporal dimension, like the mean, the min, the max. But basically pick the reducers that you think make sense for capturing relevant temporal information for your particular problem, and then do the same thing in the spatial domain if you're working in tiles. And as soon as you do that, you just apply those, and those are your expert embeddings. Obviously, also choose the bands that you want to use, or indices, which are, derived from bands. But basically I don't know how else to describe it. I think that's kind of it. It really is that simple. I wonder if you should take the next piece of this, Chris, which is wanting to hear more about the change detection experiments.
Yeah. So with the change detection experiments, we also tried to do the dumbest thing that would work, I think, which is how Krishna described the expert embeddings last time. So essentially, we concatenated a before vector. This could have been an expert embedding, or it could have been an ImageNet derived pre-trained embedding, and we added that to an after embedding in the same location.
Yeah.
So instead of a single 512 dimensional vector, now you've got a single 10 24-dimensional vector
Right.
where the first 512 elements describe the before state of the change you're trying to capture, and the last 512 elements describe the after state. And we just treated that as a single embedding vector and did search and classification in that space.
Right.
And we had some pretty good results off of that.
Yeah.
So
What were some of the, like, if you had to pick like two applications where it like actually worked? Like, I think new CAFOs worked really well, right?
new CAFOs worked really well. The really cool thing about the change, but concatenating the changes, that you can easily, very sort of trivially reverse the change. So
Yeah.
if you set the before state to no CAFO and the after state to there is a CAFO, you find new CAFOs.
Right.
If you reverse the two, you find CAFOs that disappear, that
That's
are
right.
getting
That's right.
that are getting destroyed. And this applies to any change. So there was, mining in the Amazon, and then if we reversed the sort of green to mine vector, we found mines that had been abandoned
That's
where
right.
regrowth was occurring.
That's right.
So, yeah, I really liked that set of experiments. It was really cool.
Cool. Okay, cool. We have another question. There's about there are some time series embeddings like Presto or Tessera. I don't know if I'm saying that right. Say that I do monthly composite for 3 years and then generate embeddings from such models. Is it still applicable to generate statistical features on top of these 12 times 3 time series embeddings for change detection or, I guess, land cover application? What do you think?
Wow. I mean, I don't really fully understand this question, but I would say, based on what we just described about the change detection experiments, yes, in fact, this might be overkill if you're generating
Right.
12 times 3, monthly embeddings for 12 years. I would probably say that's overkill for some sort of change detection application. Maybe not. Maybe not.
I guess it
But
depends on how nuanced the particular thing you're trying to find is, maybe.
Yeah, but it's also, if you consider the dimensionality of these, I mean, that's like 12 times 3 times whatever dimensionality Presto or Tessera's embeddings are, which is, I don't know, maybe like 200 or something like that. That seems like a lot of dimensions.
Yeah.
So I would say you could probably get away with simplifying this. That's my opinion, but probably there would be signal in there.
Yeah. Yeah. Cool. We have one more. And how should we treat embeddings for downstream tasks on top of classic ML models like the random forest? Should we perform feature selection on the embeddings, or could that degrade the performance? For example, if I choose only 10 embeddings for a particular application, should I use the same subset of embeddings in another region, or would this affect spatial transferability? My instinct here is that if you're using an embedding that's like created from some model, like you tapped into ImageNet or something, if you subsetted one piece of those embeddings for some application in one place and then use that same subset for another place, I think that you would possibly lose a ton of information, because I don't think the information content in those embeddings is sort of like neatly ordered in a way that you can just pick out. And I think this is different from like expert embeddings, at least the way we created them, which is you could like select the pieces that were like just the NDVI piece of the embedding and then use that. And you would expect some semblance of repeatability in how you could apply that to another region. But I don't think that's necessarily the case with like a machine, with like an embedding created for machine learning. What do you think?
Yeah, to be honest, I've always been a bit confused about feature selection. Like, I understand from the perspective of interpretability. Okay, you want fewer ones so that it's easier to describe their interactions. And I also understand it from the perspective of storage and compute.
Yeah,
right? Like,
for sure.
okay, we really have to throw away a lot. But if you want your model to do well, you should. I feel like you could always give it more information. And I think being afraid of overfitting I don't know. I just feel like it's actually very easy to tell if a geospatial model is overfit, or yeah, I would say so. And so I think you should just throw all of your embeddings in if you have them, unless you're constrained by storage or compute or interpretability. That's my feeling.
I think the overfitting problem is particularly interesting for Earth observation in a way that it isn't as interesting in other domains, because I almost think that there's a like if you think that every model is overfit to some degree, and if your goal is to produce a
A map.
reasonable land cover map over this place or a good detection of
Yeah.
CAFOs in Alabama and nowhere else, you
Uh-huh.
almost don't care that it's overfit. You kind of want it to be overfit.
That's yeah, that's kind of how I feel. I mean, maybe you care because next year when you redeploy the
Right,
model,
right.
so like spatially overfit, not as much of an issue. Temporally, maybe if you want a year over year map, but even then, that seems less likely to me, barring any like big changes in the sensor itself.
Yeah.
I would, yeah, I kind of agree with that. I think we overfitting is demonized, but I kind of like when my models are a little overfit, you know, to be honest. They look better. So, so yeah. All right.
Those are the
Well,
questions.
those are the questions. Please send us more, or maybe not. I don't know. Yes, please send us more. Please
Yeah,
send
you
us
should
more.
send us more, and then we could possibly get to a point where we just only answer questions for an episode at some
Oh,
point, but
interesting.
I doubt
Yeah.
we'll ever get to that kind of listenership.
Right. Right.
But I was wondering if, I think we both worked on Descartes Labs, we both use Google
Hmm.
Earth Engine, we've done like other stuff. I was wondering if we could start this by me asking you what you think, before we actually talk about specific
Hmm.
platforms, like what you think a platform should have in terms of features, and what do you think it should enable a person to do?
Ooh. Yeah, for sure. Interesting. I think the first thing that comes to mind when I think about a platform, if from an Earth observation or geospatial perspective, is scale. Like, I would like to use a platform to deploy a model at scale or sample points at scale across a lot of different areas or geotiffs. So I think that's the first thing that comes to mind. I think there's definitely also like a ease of use aspect. Like I would like platforms to be easy and intuitive, and I say this because I have
Easy in what
found,
way? Easy in like writing the code, or easy in something else, like
yeah,
the
I
abstracting
think
away the geospatial concepts or something?
I think writing the code, like I would like there to be low cognitive burden, if that makes sense.
Yeah, yeah.
That's something that sometimes I feel like can get in the way. I guess that relates to the abstractions, right? Like, what are the fundamental units of
What's
compute
like the
and
model?
storage?
Yeah, what's the model of
Yeah,
the platform?
yeah. And how do I build like this graph of operations that I
Sure.
want to do, and then how do I implement that? So I think that's the main thing, and I guess like there are things that are just really scale. So scale, I think the first thing I said was scale spatially, but when I think about it, also scale temporally, which is potentially trickier to do by yourself.
Yeah.
Like co-registering, like making sure your stack is co-registered and things like that.
Yeah.
So so I think like scale and ease of use is maybe what comes to mind immediately right now.
Yeah. Yeah. Yeah.
Yeah. What about you?
I think maybe I'll try to answer this question um by pr- by like trying to talk through how you would do something if you weren't using a platform, like if you were just doing it locally. So if you were interested in like, you can download a lot of data from just websites, right? So like the National Land Cover Data Set's a good example. It's publicly available on the USGS website. Like every year, you can download all the geotiffs for all the years or just a particular year that you're interested in. So if you were doing something across the United States where you were aggregating NLCD to like counties to figure out, I'm making up some problem, like figure out how rural or urban certain counties are by like tallying up built areas versus non-built areas from NLCD, you could do that locally, right? Like you could grab the county shapefile from the US Census Bureau. You can grab the NLCD 2024 TIFF, and then you can just use Rasterio and GeoPandas to do everything, right? Or GDAL, like you pick your favorite tool, you like write some code that loops through all the counties, clips the thing, tallies up, the land cover classes you care about, store that off in some dictionary, and then you can like run your stats at the end and create your map, right? And I think that's fairly easy. But I think even that process to do locally is like fairly high overhead. Maybe not with LLMs doing most of the work for you. Like that's a fairly simple thing. I think an LLM would just get that right the first time. But to just contrast that with like Earth, like if you were to do that same thing in Earth Engine, I think it would be like a couple lines of code.
Yep.
Grab the NLCD image collection, and it's just to reduce regions with your counties,
Yep.
with the like frequency counting
Yeah.
reducer, and
Yeah.
export that task, and you're done. So it's actually even way less code to even do it in Earth Engine, for example, which is a platform, compared to doing it locally. And I think that's what I think of a platform is like just making some of the stuff that's very easy to talk through what you want to do simple to do in terms of computation.
Yeah. That's interesting. It is a lot easier just to do that on Earth Engine.
But I feel like nobody, or maybe I'm wrong about this, but I feel like the instinct is still like, at least I had the instinct for a long time, like, oh yeah, that's just something you can do locally. You don't need a platform to do it. And you don't, but actually the platform makes it easier in so many ways.
Yeah, and like the shape files are actually already on Earth Engine.
And if they're not, you just ingest it as an asset, or you might not even have to if it's not even that big. You can just send the JSON. You can like declare the feature collection dynamically, and be done.
Right, or chunk it up or something. Although I will say ingesting feature collections into Earth Engine is a little bit janky.
It's a little janky. I mean, the whole ingest is a little janky, but
Yeah, yeah, but it can be done.
yeah.
Yeah, that's a really good point. I hadn't really thought of that. And then with the LLM generated code, I'm sure there would be like some edge cases that it would miss, like I don't know, weird county shapes or something like that. And I feel like Earth Engine wouldn't miss that, or it's like built to handle that.
Yeah. And I think the other thing too is like, let's say you were doing this locally, you have to get a few things right that I think are non-obvious. So you have to understand something about coordinate reference systems. So if you did this entire like area-based pixel accumulation in WGS84, for example, that would not be correct. And if you, because like you'd have to know that like, oh, I need to make sure that this is in Conus Albers or some other projection that does a good job at preserving area-based calculations. So, and actually in Earth Engine, you have to do that too. So you'd have to specify the CRS when you're doing the reduced regions to make sure that it's actually doing its counting correctly. But there's definitely way less steps in Earth Engine. You just give it the CRS and it does all the reprojection for you. And let's say you downloaded the TIFF and it's not in an equal area projection, you have to warp it with GDAL or a Rasterio or something.
Yeah. Yeah. so it's not even really about scale. Like from a starting point, we're already on the ease of use. Like it just seems like it's easier to do this operation on Earth Engine. But maybe Earth Engine is a bit special as a platform. I mean, when I think of doing this operation on the Descartes Labs
Yeah,
platform, it's almost like it's closer to the local workflow.
it is
You just have the ability to fan it out better.
for sure.
Yeah.
So Descartes Labs was like the core of the platform, I would say, was raster and metadata. So these were services that were offered on the Descartes Labs. And raster is basically, extremely rapid access to imagery that's cataloged in the platform in this nice Python interface. So you get NumPy arrays back over tiles of data. So the really common workflows were build tiles, build UTM tiles. There was a tiling system built into the platform. It's like
DL
build
tiles.
DL tiles. So build UTM tiles over like the entire United States. Grab an LCD, write very simple Python code, and then scale that with tasks. So then you parallelize the operation across all these tiles across the continental United States.
Yeah.
Store off all those results, roll them all up, be done.
Yep. And actually, I feel like maybe when I started using it, raster and metadata had turned into scenes. Is that possible?
Oh
Or is
yeah,
that
I
just
mean,
a
I think
wrapper
scenes
over
is
them?
just a wrapper. Yeah,
It was just a wrapper where it kind of like combined
exactly.
the two, where you could do the querying of the metadata kind of like stack, and then the pulling of the array, all using DL scenes.
Yep.
But I guess it was like under the hood, it was the same thing.
Yeah, under the hood, it was just rastered metadata. Yep.
Yep. Yep. Yeah.
And I feel like so that was the first geospatial platform I used. Was it the first one you
Same.
used too? Yeah.
Yes.
And
Yeah.
and as someone who at the same time I was using the platform, I was learning about some of these more geographic based concepts like what is a coordinate reference system, you know, what is like resolution and all that kind of stuff. And I think it did a pretty good job at abstracting a lot of that away from you because you almost, if you use DL tiles, you just immediately worked in UTM. And so
Yep.
a lot of the complication was handled for you. And then if you were like a data scientist type person who was used to NumPy arrays,
Yep.
it felt extremely intuitive and the imagery access was so fast that I think it felt extremely freeing. Like
For sure.
imagery access never felt like the problem
No.
when you were using it.
No, but I actually feel it was also the first platform I touched, and I was still in academia at the time. So there was a lot of I just want the array, and I just want to make my figures for my paper, and I just want to run the experiment. I feel like somehow, ironically, when I was in academia, or maybe because we were publishing more on algorithms than I don't know, outcomes and impact, I just never ended up picking up all that important stuff when I was using the DL platform.
Yeah.
Like it wasn't until afterwards where I started understanding like, oh, tiling is non-trivial. Like this is
Right,
why there's
right.
like pixels missing from the edge of every array I pull from the DL platform when I try and like just pull a box. I feel like I maybe like missed out a little bit because it was just so easy,
Definitely.
yeah.
I think it
And
also, yeah, I think because I didn't have to think about some of the geospatial concepts as much, I think I also developed some of the more geographic understanding later, using platforms like Earth Engine at first out of necessity after leaving Descartes because it didn't have access. So it's like
right.
just have to do work somehow.
Yeah,
It's
yeah,
like turn to something.
yeah.
And Earth Engine is almost the exact opposite in some ways of the Descartes Labs
Yeah.
like platform ethos anyways, which is like
Yeah.
you don't get any NumPy arrays back. Getting a
No.
NumPy array is a pain in the ass. And if you don't, and you're like building, instead of like get the array and go do things, it's build your graph and have no idea what's happening until you look at the end.
Yeah.
And And I think it doesn't abstract away as much because, like, you're not just working in UTM and you are
Hmm.
thinking more about coordinate reference systems and stuff. Like, I think, yeah, I think it forced me, like, using Earth Engine actually forced me to learn more of the geospatial concepts.
100%. And I actually think if you just, well, I don't know. I mean, it's backed by Google, right? But I was just gonna say, if you have used both of these platforms, it's like I would say it was a pretty painful transition for me,
Yeah.
right? Like especially because the error logging in export tasks at the time wasn't great. I think Earth Engine's improved that since. But just like, where is my array? I just want my array. Like,
Right.
why do I have to like mung around and like, I just want to do a get info at every line so I can see what I'm working
Yeah.
with. So it forces you to hold more in your head,
Yes.
but it sort of makes you think about the problem maybe in a way that you should be thinking about it.
Right. Right. I think it forces you to think about what is the right way to compose these set of operations such that it is like optimal and efficient, as
Yeah.
opposed to like grab the data whenever you feel like it and then do whatever you need to do on top of it and just make
Yeah.
it work.
Yeah, yeah. It's like you said, like the sort of like the opposite, right? It's like they came at it from a Earth observation remote sensing perspective,
Yeah.
not a data science perspective.
Yeah.
It wasn't like, oh, we use Dask and scikit-learn and XGBoost, and these are the packages we know, and we know that NumPy arrays feed into these packages, so we're just gonna build the whole pipeline to get you that NumPy array, and then you can run, your standard data science workflows. It's almost like they came from a perspective of like composites and coordinate reference systems, and how do we like leverage Google's compute, but also make sure that we are still doing our geospatial operations that make sense to us and that we want to do.
And I think I'm not sure, I don't know enough about the history of the Google side of like how all the platform decisions came about,
Yeah.
but I wonder if some of the design decisions were also around the fact that it was thinking about the overall scale of this thing in terms of like if everybody's just pulling vast amounts of NumPy arrays, like at some
Hmm.
point this thing is not going to be sustainable. And so it
Yeah.
was like almost baking in from the beginning. And Earth Engine still has very tight rate limits, the amount of data
Yeah.
you can get from get info, the number of
Yeah.
parallel requests you can send at a given time.
Yep.
Whereas with Descartes Labs, it was like, just
Just do
anybody
it.
could get arbitrary amounts of data and then the platform would fall over all the time.
Yep.
And it had, I think this is safe to say, a lot less users than Earth Engine. And so and it was like great when you were working there and you could grab sort of so much data so quickly and be annoyed that you can't do that with Earth Engine, but also I think in some ways that makes Earth Engine kind of more robust because it's not
Yep.
just falling over all the time.
Yep. I think it makes you like constraints create like creativity and skill, right? Like it makes you a better user if you can't just. I just remember to Descartes when I had access to the platform, like rasterizing these ice charts over the entire like Arctic and just blasting it. And I barely knew what rasterization was. I just knew that there was like a workflows function that would do it for me.
Yeah.
And instead of sitting down and thinking about A, do I need all of these ice charts? And B, is there a better way for me to do this? It just because it was available to me, I just ran it,
Yeah. Yeah.
and in Earth Engine, you're constantly bumping up against like, do I have to split this into different export tasks, or maybe I just do the high volume API and I just like pull a couple regions and check it first, and it really makes you think before doing something at scale because it's going to take
Yeah.
time.
Yep.
Yeah.
Definitely. I wonder if so that's like I feel like that's a good breakdown of like how Descartes and Earth Engine are different. I feel like we we've missed the whole stack open source ecosystem up
Yeah.
to this point. So I think it's important to note that Descartes Labs, they ingested data within their platform. So the platform was at the time built on Google Cloud. I think now it's on some version of it's on AWS. But anyways, there was a whole, there was a whole indexing process that was run on the data. There was basically copies of data of,
Yep.
Landsat and Sentinel, all these things. And, that costs money to store. Obviously, Google does the same thing for Earth Engine. And then, there's Stack, and then the whole model of, cloud optimized geotiffs, this idea
Yep.
that the data already lives in some S3 bucket somewhere. We should never make a copy of it. And
Yep.
we should have open source standards that define how we access this data. And then there's different implementations of that specification. And as long as you follow the spec and you have a service, anybody can hit that Stack endpoint and grab data.
Yep. Actually, before we get into that, do you know if the AWS Open Data Program existed when Descartes was like spinning up its platform, like in
Great
2018,
question.
2019?
I don't know for sure, but I want to say it was in like the really early days.
It must have been.
I think it was
Like
early
there
days.
wasn't Sentinel-2 on AWS.
Or I feel like that did happen at some point, maybe during when I was
Okay.
there.
Yeah.
But honestly, I was just so in that world at the time that I don't have a good sense of when some of these things happened.
Yeah. 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 Because I mean, with all of these open tools, you do still need the data somewhere, right? Like
You
so,
need the
like
data
right
somewhere.
now,
Yep.
yeah. And AWS is footing that bill right now.
AWS is footing
Of-
that bill. And then there's, other places where data lives and there's repeatable ways to access it.
Yeah.
I've used some Stack stuff before. I would say where I have seen a lot of that lacking, and it's possible that Planetary Computer and other platforms like that tried to kind of, they were built off of Stack, and the whole idea was that they were supporting the open ecosystem. But I think where they fit was with like a lot of Stack services that people hosted. We had a Stack service at Impact Observatory when we were doing land cover. I think there were like critical bits that weren't implemented as part of the service that I think users of other platforms take for granted. For example, like with a lot of Stack endpoints is you don't get clipping over an area of interest for free, for example. Like
Right.
you might do a metadata search and it's going to return the scenes that intersect your area of interest, and then you'll like get links to those cloud optimized geotiffs. And then it's up to you at that point to like go do things with that, right? So
Interesting.
a mosaic operation or a clip is not like baked into that. And so I think there's just more barriers to entry in some ways when you're hitting some of those services. Like it's not quite as seamless.
Yeah. If that feels more like a local workflow, right? Like I'm gonna tell you where the geotiffs are, but you're gonna have to pull them and then figure it out yourself.
Yeah,
Yeah.
I think that's right.
Yeah. Yeah. And so when you guys were doing the land cover map at IO, had you considered Earth Engine as an option?
There was a bunch of stuff already happening on Earth Engine, but I think for business reasons, there was many reasons why we were not gonna
Yeah.
not gonna do it on Earth Engine. And I think this, you I think have done a ton of stuff like talking about how much it costs to deploy stuff on Earth Engine, which
Right.
I know
Right.
I know less about because I have never been in a situation where I've paid for it, thankfully.
Yeah.
But
Thank you, Google.
but when we were making the first version of Esri land cover, and we had a very specific like mandate, like make a annual land cover map for this particular year. And it was in our interest to do that as cheaply as possible. And so I think it
Right.
made a lot of
Yeah.
sense for us to do every bit of that from scratch, like
Mm-hmm.
tiles across the world with the MGRS tiling system.
Yeah.
There was a UNet that was producing the land cover maps and like running the
Mm-hmm.
UNet over every one of these Sentinel-2 scenes that fell below a certain threshold. And so like
Mm-hmm.
we rolled all the compute specifically in Microsoft Azure at the time.
Mm-hmm.
But this was a little bit pre-planetary computer where we knew they had ingested all the Sentinel-2 surface reflectance data.
Mm-hmm.
And so we had access to to where those surface reflectance scenes lived in Azure Blob Storage. And so that was how our whole system was built. And
Oh.
so it was built in the same region, the same cloud region as where all the Sentinel-2 data lived, which is like Western Europe or something like that.
Uh-huh.
And
Uh-huh.
so that's where all the compute ran, and basically that's how the platform ended up scaling out. And I think all said and done, that ended up being fairly cheap for an annual run compared to what it would cost, I think, on probably almost any platform that is more general, that's designed to do a number of
Mm-hmm.
different types of problems. Like our thing only solved one particular problem, but it did it fairly cheaply.
Right. Yeah, that's what I was going to ask. In this context, the platform is pull Sentinel-2 data over an MGRS tile,
Yep.
chip it up, deploy a UNet,
Right.
repatch it together with overlap,
Exactly.
and then save that somewhere,
And
basically.
then you write out all the individual land cover predictions for every time step in the year, and then
Mm-hmm.
you run another process that does like a weighted mode across that,
Mm-hmm.
over every tile to produce the quote unquote final map.
Yep.
And the intermediate products are like, geotiffs, cloud optimized geotiffs in blob storage.
Yep. Yeah. Yeah.
Yeah. And I feel like there's real value in building every piece of that from scratch. Like apart from just learning a lot, you I think get to optimize a lot of things that make sense for your problem. But
Mm-hmm.
I definitely wouldn't call any of that a platform. I would just-
Yeah. I think that's really interesting. It does seem like the cheapest way to do that is just do it yourself, spot instances, compute in the same region.
Yep.
Like you get to make those decisions when you're rolling your own.
Right,
And
right, right.
in Earth Engine, if you're a non-commercial user, you don't really have to worry about pricing. But if you are a commercial user, and I think they've only had commercial users for like 3 years, I think they started in 2022, that bill can run up surprisingly fast. I think at Grow Intelligence, actually the first iteration was maybe like on some free account because we were in the process of interacting with Google and getting the commercial accounts set up and the
Yeah.
cloud projects and everything. And it just never occurred to me that I was doing such a crazy thing for free. And then the bill came around and deploying a random, and I was not doing this particularly effectively at the time, but deploying a random forest over Malaysia and Indonesia to detect oil palm, it was costing us, like one annual run was costing us, thousands of dollars. And I had just been sort of like tweaking something, rerunning it, tweaking something, rerunning it, and I realized like, oh, I need to now start being careful about how
Yeah.
I'm using all of it. But I guess it kind of makes sense when if you think about it as a premium on compute and storage, right? Like that's what the platform fees are, like a convenience fee
Yeah.
almost. That at the beginning it makes a lot of sense because you probably value convenience in order to like get things off the ground very quickly.
Right.
But then once everything's kind of established, that convenience, the leverage of convenience maybe goes away a little bit. but you're still paying the same cost for it over
Yeah,
time.
like if you find the thing that's sticky that you want to do over and over
Yeah.
again, it might
Yep.
not make sense to do it on Earth Engine once you've done it once.
Yep. Yeah. 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 And actually, I do want to talk about this. At the time, when I say I wasn't doing this right, I had this. I still wanted I still wanted the arrays. Like
Right, right.
we were developing a model. I wasn't sure if it was definitely going to work, and I wanted to be able to throw a potentially different model at the data, the underlying data, if I wanted to. I mean, obviously the random forest worked, yeah, and there's the Earth Engine random forest implementation,
Right.
which I think in hindsight I probably should have just used that and just deployed it and gotten the mask out.
Oh, so you
I
were
was
getting the data out and then running
yeah,
your own? Wow.
I was getting the composites. Yeah, I don't know why. I just felt like that was the way for me to iterate if I needed to. I didn't
Right.
actually to if I had known how strong of a signal oil palm has in Sentinel-1, I wouldn't have. It's just
But
I
it's
had
hard to
spoken
know
to yes.
until you look
Yeah.
at it.
Yes. Yeah, I just spoken to so many people who had, oh, I've tried it and we tried this and we tried that and it just turned out to not be that difficult of a problem, at least in the areas I was looking at.
Right.
So and
But it's so
the
hard
other
to know.
thing,
So you like guess in some. So like if you just did it in Earth Engine and you're coming at it for the
yes.
first time, you guess at some input feature space. You you do this one liner that's like train random. It's like random forest
Yes.
dot train or something.
Yeah,
And then
and
you
then
just
stop.
deploy it over the map. You look at it and you're like, well, what do I change?
Yep. Yeah, there's not that flexibility, and
Yeah.
also I think I wanted the probabilities
Right.
to
I
like.
think you can get that from the Earth
Can you
Engine
do that?
output. Yeah, you can. Yeah.
Oh, damn! I
But
should have
it's
done
like,
that.
but
I
it's,
wanted the.
again, none of this is like particularly obvious.
It's not. It's called Smile. I'm
Yeah.
looking at it now. It's called ee.classifier
You have to
dot
set the,
smile random
yeah.
forest.
And then you have to set you have to set you have to call a different method on the classifier itself that like sets the output mode to
Right.
probabilities, and then you can get the probabilities out. I've gone through this a few times. This is the only reason I know this.
Yeah. Yeah.
But
Yeah.
even with the probabilities, then it's like to design an experiment where you're like doing a true input feature selection search and hyperparameter search in a way that I think many data scientists are used to setting that type of thing up in a Python environment, right? Like
Yeah.
with scikit-learn, it's like you got all this nice framework for setting that up and evaluating
Yeah.
exactly how well each one of these things worked. I think doing that in Earth Engine is not as clean by a long shot.
No, but I think
You
you
could.
almost certainly could. Yeah.
You could.
There's like this. You can get the confusion matrix out,
Right.
right? Like from the trained classifier,
Yeah, you can.
or something like that, and then
They
plot
thought of
it.
everything. That's the thing.
They it's crazy. Like they really thought of like, what if we just did everything in Earth Engine?
Yeah,
Like,
yeah.
which I think is maybe unnecessary, and I do think they're probably moving away from that a little with Vertex and being able to deploy custom models and just, connect them straight to Earth Engine. But I would love for the other platforms to make it as easy to deploy a pixel-wise random forest on them, right? Like a couple lines of code, basically.
Right, right. The Vertex stuff, in my opinion, and to be fair, I haven't used the latest iterations of these from the past couple years, because I'm not in a position where I have unfettered like access to the Google Cloud ecosystem. Like I have
Right?
very specific access due to what my company allows. But the Vertex connection is extremely non-intuitive. Like
Oh,
like
man.
to get a
It's
neural net working in Vertex and deploying in your like in your map application is, I think, like heroic levels of effort. Or at least it used to be.
I think it's just a very opaque process, right? Like and there's like rate limits on vertex, like quotas that you have to change, and if you don't, it just fails silently. I think when it does work and you've got a model deploying, just inferencing live, and you're panning around in the Earth Engine code editor or on Gmap, that is pretty cool.
Yeah. Which is like how random forests work, which is insane.
Yeah,
Yeah.
yeah, it's pretty crazy to do that, to be able to do that live. But I agree that I think there must be a better way to do what they're doing, and I think maybe for commercial users, people could just maybe bring their own compute from
Yeah.
the Google Cloud platform. You know, like maybe we could just give people access to the cogs and that are clearly stored somewhere, and maybe charge them a little for egress and all of that. But they could bring their own compute, and and they had that way you kind of have like the most flexibility. I
You're
feel
talking
like
about
if you
them to have a little backdoor raster implementation.
yeah. Yeah, yeah. I think it would be great for Google Cloud. You know, like I think that it would be like a lot of people are turned off by Earth Engine because of their impression of Earth Engine is like writing JavaScript in the code editor. And
Yeah.
and actually, to be honest, a lot of it is like if I
Yeah,
don't know
totally.
if like the Landtrender implementation by I think it's like Justin Bratton. I hope I'm saying that right. Like I think that's a JavaScript repository. There's a ton of really sort of complex code that's written in JavaScript, and data scientists like to work in Python. And I just feel like if we just could allow people, yeah, the backdoor, the raster backdoor. I don't know, like why not? When you're ready to deploy finally, like just do it through that instead of via Earth Engine where you're paying, this premium that maybe you don't need to pay. I don't know. Yeah, yeah,
I think yeah, Earth Engine these days for me has basically been a godsend. Like the amount of data you can crunch through in so little time. Like
yeah,
no tool is better at creating extremely complex composites than Earth
yep,
Engine. I don't even
yep,
think it's close. And I think when you set up your graphs correctly and you're combining multiple data sets, I think where it really shines is when you're like, you have some input data and you're masking it with another from
yes,
a derived thing from another data set. And those
yes,
things aren't necessarily at the same resolution. God knows
yeah,
how they were ingested.
yep,
And then you just keep building and building and building like that. That's something that Earth Engine is exceptional at.
yep, and it's
It just
underrated.
yeah, and it abstracts so much complexity for you in
Yep,
a way that is actually fairly intuitive in terms of writing the code. It's like, yeah, I just update the mask here and I reduce the resolution here,
yes,
and it's like boom, boom, boom. It's like that would be very complex to implement correctly
yes,
locally.
yeah. The hardest part in Earth Engine is remembering if the mask is the pixels you want or the pixels you don't
I
want.
still have to check half the time.
Yeah, yeah. That's a great point. I think, yeah. I mean, this is really turning into Earth Engine podcast. I guess it makes sense because it's the platform we like the most. But
Yeah, it is.
the ability to do that intersection and mask by is so underrated. I think, and again, it's like coming at this from a remote sensing Earth observation perspective, where you're like, oh, I'll have to overlay these various layers to get my final answer, and then the opposite, which is the machine learning data science perspective, which is I have all my features, I have all my pixels, I just need to train a big enough model or a good enough model, and that will solve all my problem. I'll probably not have to do that much post processing. I won't have to filter by land cover, all of those kinds
Yeah.
of things, and the fact that it's so easy to intersect data sets and that Earth Engine has such a large catalog via
Right.
the official Google datasets, but also the
Community.
awesome, yeah, the
Yeah.
community datasets. It basically means that anytime you have data, if you can put it into Earth Engine, you can immediately intersect it with every other dataset on Earth Engine with
Right.
like 2 lines of code. It's
Yeah.
just so simple. Yeah.
It's truly insane. Yeah.
It's pretty insane. I mean, a practical example is with the oil palm map, because it was a pixel wise model and it was using Sentinel-1 features. Sometimes built areas would show up a little bit. And
Land cover
when I
data set.
first, yeah, when I first saw this, I was like, oh, I'm going to have to resample some points. And then I was like, wait a minute, I'll just use a land cover map and just remove those samples
Right.
because I know that the oil palm, even if there is like a tiny oil palm stand in this city, it's not the kind of oil palm I'm interested in. And it was just done in like less than half a day, the post processing.
Yeah. And I feel like that kind of post processing with urgent, which is like a very Earth engine-y thing to do, I feel like is quite underutilized. I feel
Yes.
like everybody thinks that. I feel like when a lot of solutions I see are very much like this is the problem we're trying to solve, and then we're trying to
Hmm.
solve it as well as possible with X, Y, and Z techniques, and
Yeah.
this is how well we do, and here's where it fails. And I
Yeah.
think when you're actually solving problems, you get to use the entire world of products that everybody has created.
Yeah.
And like land cover maps have gotten fairly good, you know, fairly good, I would say.
Good enough, I
Good
would say.
enough, yeah. And
Yeah.
I think just those types of post processing filtering steps of like, oh yeah, and
Hmm.
then I can just use this other data set to then get rid of all this noise, and then I don't have to touch my model in the
Yeah.
slightest.
Yep.
I feel like that's often not the instinct. The instinct is, oh, my model needs to figure this out by itself.
Yeah. I I wonder if that's kind of like the academic mindset, which is like
Right.
we need novelty.
Yeah.
And novelty is like a model that can one shot this problem,
Right.
even if you could solve it some other way.
And then Earth Engine just lets you so easily use the ecosystem. I think that's yeah, it's a huge power, and I feel like they're kind of building a moat with the Cloud Score Plus stuff, dynamic world,
Right.
embedding fields. It's like they just make it easier and easier to grab data, and some of this data only lives on Earth Engine and nowhere else.
Yep. Yep. Yeah.
So good
And
for them.
it's hard. Good for them. Yeah. I think I do have some concerns about, how long is this going to be free for?
Yeah,
Because just, the pressures of commercialization and everything like that. But I
right.
just feel like, there's a lot of hype around. Actually, I don't even know if there's a lot of hype. There's hype around agents. And I just feel like if someone were to build a useful agent, it's probably a geospatial agent. It's very likely going to be Google because they have the tools set up for an agent to do something like that. Like if it could think through, reason, and be like, oh, I might want to use this land cover map and
Yeah.
intersect it with this. If you could just do an Earth Engine tool call,
Hmm.
it can do those experiments. Whereas on other, touching the array seems like there's way more complexity in
Yeah.
asking like an autonomous agent to do that operation even.
Right. 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 Yeah, that's a really good point.
Yeah. Not that I know if agents are going to be a thing or not, but
Yeah.
if they are going to become a thing, I think Google's going to do it at least for
Mm.
geospatial,
Hmm.
just because of the tooling that they've built.
Totally.
Yeah. Okay. Is this an hour? I don't have the time on my clean
We're
feed.
at 58 minutes.
Wow.
Yeah.
I just have a sense.
You just have a internal clock.
Do we want to any closing arguments or statements?
What is my closing argument? I don't know.
I think it's that we love Earth Engine.
Yeah.
Again, if anyone from Google is listening to this, please give us more export tasks. We would like more export tasks, please. Yeah, and I guess the general feeling is that maybe some of the other platforms are coming at this the wrong way, maybe, or I don't know. I don't want to say the wrong way. In a way that that doesn't jive with me as much.
Right. I think it's
My way of problem
I
solving.
feel like, we in this discussion we have had massive gaps. I think partially because we haven't used a lot of the other
Yeah.
tools as much. But I
Yeah.
think some of it too is that when I've tried to use some of these other tools, I haven't gotten anywhere that quickly.
Yeah.
And there's some sense of like, yeah, when a platform is kind of limited, it's almost like worse than doing it all by yourself. Like if you can't
Yeah.
quite do it all on the platform, it's like, but you can do some of it or a piece of it. There's something about it where that makes me not want to use it because it can't get me to the result.
I think that's a good point. I think the fact that we haven't switched over to anything else since Earth Engine is probably a statement about the stickiness of Earth Engine, and the non-stickiness of other platforms we've tried.
Yeah. And yeah, I mean, and in my current role, I'm in a situation where I have to deal with more data from more places than I normally would because I'm for a particular story, I'm like grabbing data from here and there and it's not cataloged
Hmm.
anywhere and it's just a file that lives somewhere else. And I sometimes ingest that data into Earth Engine as assets, and the ingest process is non-ideal in a lot of ways, but it does
Yes.
work. And then once
Yeah.
it's in there, you can write all the same code. But
Yep.
but often I just go local a lot of the time,
Hmm.
and so I still rely a lot on local processing. So I think as much as I love Earth Engine, I still don't use it for everything. I'm still using GDAL and
Yep.
Restereo all the time.
Yep. Yeah. I guess since people leave comments, if you have built a company on Planetary Computer for technical reasons have chosen this platform over Earth Engine or anything else, I guess we would like to hear from you
Yeah,
about your reasons, about your reasoning and why that is the case. Even if it's pricing, that's interesting to us.
for sure.
Yeah,
Do you have any closing thoughts?
that was my closing thought,
That was your
Krishna.
closing thought. Okay.
No, I think I always get the feeling that we people discount Earth Engine for some reason. Well, I know the reasons. Like the code editor definitely needs a refresh. Maybe it could, maybe you could write Python in it too. But we have Jupyter notebooks now, so I guess that's not as big of an issue. And Gmap and stuff like that. But I think it, there's a lot of technology being built around the array approach, and I would encourage people to just check it out, Earth Engine, and see if it can fulfill a need, because I think it's underrated, I would say.
Still underrated to
This way.
this day, huh?
I think so. Just from talking to other people, like
Yeah.
people are very much in the Dask
Right.
and even like czars now
Yeah.
over cogs and things like that. But I just think you can not have to think about those problems, if you know if you don't if there's maybe not like a latency issue, or yeah, I mean, I guess pricing can determine that as well. But
Right.
worth thinking about.
Right.
Yeah.
Cool.
All right. Well, thanks.
All right. See you later.
All right. See you later.